Radiation plays a critical role in our universe and is present in everything from the stars in the sky to the rocks on the ground. There are different types of radiation, each with its own unique properties and effects on living organisms. See our video about the electromagnetic spectrum to understand more about this phenomena. In this video, we will explore the four main types of ionizing radiation: alpha, beta, neutron, and gamma. Ionizing radiation is produced by the nuclei of atoms. When an atomic nucleus undergoes a change, it can release energy in the form of ionizing radiation. This can happen naturally, such as in the decay of radioactive isotopes, or through man-made processes, such as nuclear reactions or X-ray machines. These four types of radiation have enough energy to knock electrons out of atoms and damage DNA. They are dangerous in case of intense exposure. Alpha particles. Alpha radiation is made up of alpha particles, which are positively charged particles that are made up of 2 protons and 2 neutrons. They are not very penetrating and can be stopped by a sheet of paper or a few centimeters of air. However, this characteristic makes them dangerous when they are inhaled or ingested, as they can deposit a large amount of energy in a small area of tissue, which can lead to cellular damage and an increased risk of cancer. Some natural sources of alpha particles include radon gas, radium, uranium, and thorium cosmic rays. Did you know that tobacco smoke contains small amounts of polonium-210, a radioactive element that produces alpha particles when it decays? In resume, alpha radiation can cause damage to living organisms, but is easily shielded by materials such as paper, skin, or clothing. To minimize exposure, it's important to take precautions such as avoiding inhalation or ingestion of alpha-emitting substances. Beta radiation. Beta radiation is made up of beta particles, which are negatively charged, similar to electrons. Recalling, ionized radiation is emitted by the nucleus of atoms. In this case, an electron is emitted when a neutron transforms into a proton, in a process called beta- decay. Beta particles are typically emitted from lighter elements such as carbon or potassium, which are found in many natural sources. Beta particles can be stopped by a thin sheet of metal or a few millimeters of plastic. They have smaller mass than alpha particles but more penetrating, capable of passing through human skin and causing damage to living cells. Neutron radiation. Neutron radiation are again released from the nucleus of an atom, either through decay or as a result of a nuclear reaction. The released neutrons can then interact with other atoms and produce additional radiation, including neutron radiation. They can also be created when high-energy particles from space interact with the Earth's atmosphere, and in elements such as uranium and thorium. Neutrons are highly penetrating and can pass through many types of materials. To protect ourselves from neutron radiation, it is important to use dense shielding materials such as concrete, lead, or heavy water can effectively reduce exposure. Especially water. This is because water works here as a moderator, which means it slows down fast neutrons, allowing them to be captured by atomic nuclei in the water. Gamma radiation. Gamma radiation is made up of high-energy photons, which are particles of light and is created during the decay of atomic nuclei. Gamma rays are similar to X-rays, but have higher energy and can penetrate materials more deeply. The only materials that are effective in absorbing gamma rays are very dense materials, such as lead, concrete, or steel. We hope that this explanation of the different types of ionizing radiation has shed some light on a topic that is often not well understood by those outside the field of physics. Please subscribe our channel. Thanks for watching.